Okay. Extrema is just the plural form of way of me saying your extreme values. It encompasses all of your extreme values, your maximums and your minimums. So it's the maximums and minimums of a function. Okay. When it says, what is the difference between relative and absolute extrema, can you give an example of each? Give it a sketch. So an absolute extrema, or absolute extrema, um, are the highest or lowest um, values a function attains on its domain. But we can just say attains. And then relative extrema are highs or lows on a portion of the domain, but not necessarily the entire. Okay? So if I have an x and a y, and I were to draw, let's say, something like this. This maximum right here is a relative max. This right here is actually a minimum in this locale. It's like it's a low point, right? So that's a relative min. But this right here is the absolute highest it goes, so this would be an absolute max. And then there we go. And an absolute min, this function wouldn't have one because it decreases forever. Or not decreases forever. It does decrease here. It's increasing forever there. But it does go down to negative infinity on the y-axis. So there is no single absolute minimum. All right, number 5. How many different transformations? Okay, so this one was an interesting one. So transformations done to polynomial functions can be kind of placed like this. Negative a times f of, I'm going to go negative b, and that'll allow me to encompass everything. Negative b times x minus c plus d. And I'm going to kind of put, okay, so f of is just my function notation. Everything else is acting on a function, all right? This is a reflection over the x-axis. This is a reflection over the y-axis. This is, you're multiplying it by f of, that's you're multiplying it by your y values. So that is a vertical stretch or compression. And we'll explore all these even more later. Whereas this right here, you're multiplying it by the x, this is a horizontal stretch or compression. And then on the interior, you've got this right here. This is your horizontal shift. It's changing your x. You're adding or subtracting to x. So it's your horizontal shift. Whereas this at the end is your vertical shift. You are adding it again to f of, so you're adding it to your y value after you've done the transformation to x. You're adding it, so you're changing your y. So vertical shift. Okay, so say I had the function y equals, and I'm going to put all this stuff in there, negative 2 times the square root. So that's my function. That's my f of. Let's go negative 3 times x plus 1 plus 4. Okay, so I'm going to number off the technical order in which you would have to perform the transformations, and then kind of the general order, like if I'm actually going to sketch something, what I do. First off, the shift, or I was going to say shift, sounded like something else, stretch and compression, right? These I would do first. So the stretches and compressions, I would do those first. I would apply them and then go from there. The next I would do, technically, is that this has to be number 2. Then this, the interior, has to be number 3. Then this flip would be 4, if it's there. And then this would be the 5th thing you do. But the easiest way to do this is actually in this order. So I'm going to write that again. Y equals negative 2 times the square root of negative 3 times x plus 1 plus 4. The order is actually easiest done by 1, then the flips, at the same time 2, then the shifts at the same time 3. So stretches and compressions first, reflections next, and shifts last. So you can do these 2 at the same time, you can do those 2 at the same time, and you can do these 2 at the same time, and you will end up in the correct spot. Okay. And that's a good enough example. We're not, I mean, I'm going to get into that when we actually learn a lesson, like when we're graphing functions and doing all that. So I'm not too worried about really getting into it right now. But it'll be nice to have that written down somewhere or drawn somewhere. And if you wanted to do the 1, 2, 3 with this right here, that would not be a bad idea. Okay. Number 6. Okay. I'm going to do 6 and then I will start a new video. So it says in behavior. So in behavior is a big deal. If I have a function and I'm trying to describe where it's going on the ends as x approaches the infinities. So say I have, let's go with a quartic that does this, right? Then what I want to do is I want to describe as x approaches negative infinity what y is approaching, because that's what a limit is. It's what the value is approaching. And the easiest way to think of it is like this. As x goes to negative infinity, where is the function going? So if I go left, the function is going down to negative infinity. Whereas over here, as x approaches positive infinity, what's the function doing? And that could be a y or an f of x, doesn't really matter. They're interchangeable. As as x goes to the right, the function is still going down to negative infinity. Which means that I could write the limit as x approaches both positive and negative infinity is negative infinity, because they're both negative infinity. I'd like to pick a few more. I'm going to pick some interesting ones, okay? So let's pick the exponential. And I'm going to pick exponential decay. So something like this. Okay? So exponential decay, it has that horizontal asymptote. I'm making it be at 0. Horizontal asymptote. And if I want to find the end behavior, then it is the left-hand limit as x approaches negative infinity, and the right-hand limit as x approaches positive infinity. So here we go. As x is approaching negative infinity, as x goes to the left, where is my function going? It's going up to infinity. So that would be my answer. But over here, as x is approaching positive infinity, my function is actually getting closer and closer and closer and closer to the horizontal asymptote, which is 0. So on the left, I know my function is going up, but on the right, I know it's leveling off to a number, and that would be 0. Okay, so a little bit more interesting. And then if I were to pick, say, the square root, right? So if I picked the square root function, and I just picked the general one like this, the limit as x approaches negative infinity versus the limit as x approaches positive infinity. So if you think about it like this, as x approaches negative infinity, where's the function going? It's not there. So for this, we would just say the left-hand limit does not exist. So that's a D for does not exist. Okay. Whereas over here, as x is going to positive infinity, the function is going up. It's just slowly, but, and there we go. Alright, I'm going to end this video and start again at number 7.